Hey everybody, it's Coach Hammock coming to you from beautiful Georgetown, Texas, here in room 132. Hoping you're having a good day. Today we're going to be talking about substituting. All right, and I know you're like, oh, we have a substitute. No, I'm sorry, I'll probably be here tomorrow. But we're talking about substituting to solve equations. So yesterday what we did is today in class, we worked on equations that are solved on a graph. All right, so we've got our graph. And the solution, like if we had this line right here, I don't know, I'm just putting it right there, and we had this line right here. Well, our solution is going to be this point right here. Well, what if we, and you know there's formulas that this would be, just looking at it real quick, y equals x plus 2. This would be y equals negative x. So hopefully that's pretty close to what the solution for that would be. All right, but what if you don't have it on a graph? And that's what we're talking about today. Well, there's a way that we can solve it, and it's called the substitution method. All right, and so let me get us to that page. Here's what we're going to do. When necessary, we're going to solve at least one equation for the variable. All right, and then we're going to substitute resulting for step 1, then solve it. Substitute the value from step 2 into the other equation, solve it, blah, blah, blah. Let's get to it. I'll show you what we're going to do. Okay? So what we're going to do is we're going to use substitution to solve this system of equations. Well, we've got a y equal to all of this stuff, which means we could take that and put it into y and solve for x. What that's going to look like is this. We're going to have 2x plus parentheses negative 4x plus 12 equals 2. Now the reason I say parentheses is wherever the y is, all of this mess is going to go into just that. So if there's a coefficient or something on y, we have to put it right here and distribute it out. Fortunately for us, there's nothing to distribute, so I'm just going to rewrite 2x plus negative 4x plus 12 equals 2. I'm going to erase that plus sign because it's going to drive me crazy. All right, so now we're going to look and see if there are any like terms that we can solve. So negative 2x plus 12 equals 2. And so to solve this, I'm going to subtract 12 from both sides. I come up with negative 2x equals negative 10, x equals 5. So now that I know that x equals 5, what I can do is I can take that back to the original problem and put it in for that x value right there. So if the original is y equals negative 4 times x, or in this case times 5, plus 12. So now we're going to go through here and let's see, that would be y equals negative 20 plus 12 and y equals negative 8. So I've got an x value that I solved, I've got a y value that I've solved. The solution to these problems is 5, negative 8. Now, I imagine if you took this line right here and then you changed the second equation into slope-intercept form, it'd be y equals negative 2x plus 2. You would see that those two lines cross at the point 5, negative 8. You can also go in and check these 2 points by putting them back in and seeing if they work. 2 times 5 is 10, plus negative 8 would be 2. So I know that both of those check out. 5, negative 8 is our solution to this problem. Okay? All right. There you go. All right, so we're going to use substitution to solve this system. All right, so I'm going to go ahead and get it to where we can write on it here. Y equals 2x. Substitution is great if you're given a system where one variable is already solved out. So now all we're going to do is we're going to put that into this y right there. 3x plus 4 times 2x equals 11. So we need to distribute that out and we get 3x plus 8x equals 11. 11x equals 11, so x equals 1. Now guys, from what we were talking about going over our test, Once you get that, go back to your answer choices if it's multiple choice and just work smarter and not harder. C cannot be the answer because X is not 1. It's 2 right there. D cannot be the answer. It's either going to be 1/2 or 2. Now, you could probably go in and put it in there and see what works, but I'm going to go ahead and solve it out with the y equals 2x. Y equals 2 times 1, y equals 2. So it looks like B is going to be my answer where x is 1 and y is 2. Okay, and remember, you can always go back and check both equations. Check it at both to make sure that they work. Okay, let's see if I got it right. Hot diggity, I sure did. Alright, so let's go right here. We're going to use substitution to solve the system of equations. We've got this. Now, this one's a little bit more difficult because nothing is solved out. So what I need to do is I need to pick either the first one or the second one and solve for one of the variables. Well, things I'm going to look for are variables without coefficients like this x, and then ones that would stay positive because I really like positive variables. But I'm going to solve this top one right here, the x minus 2y equals -3. And the way that I'm going to do that is I'm going to add 2y to both sides. And then I'm going to go x equals 2y minus 3. So now I've got it solved for this x value. I can take this 2y minus 3 and go to the other equation and put it in for x. So if I was to do that, it would be 3 times 2y minus 3 plus 5y equals 24. So now I solve this just like a regular equation where I distribute out, and it's 6y minus 9 plus 5y equals 24. Combine like terms, 11y minus 9 equals 24. And then I just keep working. Add 9. 11y equals 33. Y equals 3. So now that I know that y equals 3, what I'm able to do is to go up to the original formula right here and put a 3 in for y. And that becomes x minus 2 times 3 equals -3. Well, I have x minus 6 equals -3. I'm going to add 6 to both sides. And I come up with x equals 3. So my formula, my point, my solution to this is when x equals 3, y equals 3. So 3, 3. And again, if you were to fill this out and put it on a graph, you're going to have two lines that cross at 3, 3. All right, let's keep going. There we go. Find the value. Sorry, we already did all that stuff. All right, just a little problem for you to work on your own, and we'll see how you do. Go ahead. I'll give you a few seconds to pause it, do your work, and then check your answer. And there's the 12:36 bell. All right, let's see what you got. Answer's A, -2, 6. So if I put a -2 into x and a 6 into y, both of these numbers check out. All right, so let's keep going. All right, so when we were talking about solutions, there were three different things that could happen. You could have one solution where two lines cross, okay, and let me just draw that real quick, okay, like one line there, one line there. So the only solution we would have is that line right there. You could have infinitely many when two lines stack on top of each other. Or you could have no solution where two lines are perpendicular. All right. So the same is true for working out substitution problems. We worked it out before. The problems we worked before in this video are where there are one solution. But what if there's no solutions or infinitely many? What are you going to get when you work those problems out? Okay. Well, let's work this one out and see which one of these two things happens. So I'm going to use substitution to solve this. Well, it looks like the bottom numbers would be easier to solve. So I'm going to subtract y from both sides, and I'm going to get x equals negative y minus 2. So now I can take this negative y minus 2 up to the very first one and put it in, not for y where I drew my line, but I'm going to bring it over and I'm going to put it in for x because x equals that. So let's look at the first number, 2 times negative y minus 2 plus 2y equals 8. Now if I distribute this out, I get negative 2y minus 4 plus 2y equals 8. Well, if I combine my like terms, I've got a negative 2y and a positive 2y. Those would actually cancel out, and so I'm left with a negative 4 equals 8. And is that true? No, it's not. So this is actually going to be no solution. Alright, there are no solution for this. And what you could do is you could actually put it into y equals mx plus b, and you could see that both of these are going to give you a slope of negative 1. And remember, if the slope is the same and the y-intercept is different, then you're going to have no solutions. These are parallel lines. Okay? All right, going on. Distribute, good. Let you have a question right here. Go ahead and work this out, and let's see what you come up with. All right, let's see what it is. Infinitely many. So this is different than the no solution. So let's take a look at it and see how we got there. Okay, now looks like either one of these is going to take a couple of steps to solve. So I'm going to go ahead and solve the top one. All right, and let's solve it for x. We have 3x minus 2y equals 3. So if I solve it for x, I'm going to add 2y to both sides. And I come up with 3x equals 2y plus 3. Well, I'm going to divide each side by 3 and come up with x equals 2/3 y plus 1. Alright, so now I'm going to put it into this formula for x, and it's going to be kind of nasty looking, but we'll get it going. Alright, so negative 6 times 2/3 y plus 1 plus 4y equals negative 6. Well, if I distribute this, negative 6 times 2/3 is negative 12/3, which is negative 4y, minus 6 plus 4y equals negative 6. Like terms cancel out, I'm left with negative 6 equals negative 6. That is a true statement. That is why we have infinitely many solutions. We are left with a true statement. If it would have been a false statement, we would have been left with no solution right there. Okay. All right. Guys, we are going to do lots of work on this tomorrow. I'm not going to spend a lot of time going over it, but we are going to spend lots of time practicing, and I will be helping you work problems on this. Substitution is a great thing to know because it takes a lot of stuff that we've worked on, especially solving for literal equations. You know, when we have a problem like an area problem and we have to solve for the height of something, it's really drawing on that skill to be able to solve for the variables and get better at that. So hopefully this was not too bad for you. I know it's a longer video, 14 minutes, but we'll see what we've got. All right, guys, we'll talk to y'all later. Bye.